So that's what sigma notation means, right? So the first thing that we do, there are two ways to do it. In my notes, I have both. I have the truth table one, and then I also have the this one where we're going to represent this, put this in a binary representation, and then we're going to convert it to decimal, right? So now for a variable that's not complemented, for example, this A is high because there's no bar on top, and then this B is low, right? So if it's high, we represent it by a 1, and then if it's low, by a 0, right? So we say high is equals to 1, and then low is equals to 0. So it's just a binary representation. I know we've discussed this many times. Some of you are bored, but it's fine. Let's move quickly so that we can move to the next one. So A, it's 1, then B is going to be 0, then, yeah, and then C, it's 1, and D, it's 1, right? High, right? Then plus, so everything here is low because it has a bar on top. So this is 0, 0, 0, 0. And then here, everything is high because there's no complement. So it's 1, 1, 1, 1. And then here is 0, 1, 0, 1, 0, 1, 0, 1. Here it's 1, 0, 0, 1, 1. And then here 1, 0, 0, 0. And then here 1, 1, 0, 1. And then here 0, 0, 0, 1. So we basically have the binary representation of this. So we're going to take this and then just convert it to decimal, right? So now when we convert to decimal, we know that, for example, this is basically for a four variable term. So we know the first one is 2 to the power 0. Everything to the power 0 becomes a 1. 2 to the power 0. The second one is 2 to the power 1. This one, 2 to the power 2. And then the last variable is 2 to the power 3, right? We know the value of 2 to the power 0 is 1. This becomes a 2. This becomes a 4. And then this becomes an 8, right? So what we're going to do is that we're going to check on this position, on this bit position. You see, for example, 1 is present. It means this one is present, right? So it's basically 1 multiplied by 2 to the power 0, which gives us a 1. And then here, this one is present. What is it? It's 1 multiplied by 2 to the power 1, basically 1 multiplied by 2, which gives us a 2. Here, 0 is not present, so this bit is not present. So this we can just put a 0. We say 0 multiplied by 4, right? It's going to give us a 0. Everything multiplied by 0, it's a 0. Then 1 multiplied by 2 to the power 3 or 1 multiplied by 8, because this bit is present, right? So the bits that are present here, it's this one, it's this one, 1, and then it's this 2, and then it's this 8, right? So 1 plus 2 plus 8 is 11, correct? Guys, please stop me if I can't see hands because I'm sharing. So for example, we're going to take everything that's present here, right? So what's present here, this bit is present, which is 1 multiplied by 1, it's 1. Then here, 1 multiplied by 2, it's 2, right? 0 multiplied by 4 is 0, so 4 is not present. 1 multiplied by 8, 8 is present. So we add everything that's present, it's 8, 2, 1, right? Which is 11. So we have 11 for that. This one is nice and simple. So we say 2 to the power 0 is not present, 2 to the power 1 is not present, 2 to the power 2 not present, 2 to the power 3 not present. So all these lights are off, right? So 1, 2, 4, 8, all of them are not present. So the answer here is 0. So 0 multiplied by 1 is 0. 0 multiplied by 2 is 0. 0 multiplied by 4 is 0. 0 multiplied by 8, it's 0. We add everything together, we still get a 0, right? So here everything is present. So it means 1 multiplied by 1, 1 multiplied by 2, multiplied by 4, multiplied by 8. So everything here together, when we add it, is going to give us a 15. 8 plus 4, 8 plus 4 is 12, plus 2 is 14, plus 1 is 15, right? And then here, 1, 2, 4. So this one is present. 1 multiplied by 1, 0 multiplied by 2. This is not present. 2 is not present. 1 multiplied by 4, 4 is present. 0 multiplied by 8, so 8 is not present. So what's present is this bit here and this bit here. So it's a 1 and a 4, which gives us a 5, right? And then here, this is a 9. But how do you know that? Okay, this bit is present, it's a 1. 2, 0 multiplied by 2, this one is not present. 0 multiplied by 4 is not present. 1 multiplied by 8 is present. So already we know this one is a 8 and this one is a 1. So everything is 9. So these two are not present. Added together, it's a 9. Then here, 1, 2, 4, 8. This is a 8, but let's see, why do we say that? 0 multiplied by 1 is 0. 0 multiplied by 2, 0. It's not present. 0 multiplied by 4, not present. 1 multiplied by 8, it's a 8. So everything here is not present, only the 8 is present. So it means only the light on A. Let's say your car has got 4 doors. Maybe the driver door is the one that's open. You get my point? So for this combination in a truth table, this will be on. So it's a 8. And then this is 1, 2, 4, 8. So I'm sure it's a 13, but let's see. 1, sorry. Okay, 1 multiplied by 1, because 1 is present, we need the 1. 0 multiplied by 2, 2 is not present. 1 by 4 is present, 1 by 8 is present. So 8 plus 4 is 12, plus this last one is 13. Right, and then 13. And then this one we know it's a 1, right? 1 multiplied by 1, because only this bit is present. Everything here is not present. 8, 4, 2, nothing is present. So this one is present. So it's going to be a 1. So what I normally advise as well here, it's nice this time around because your lecture is the one that marks, but in the past, I think there were markers, right? So if there are markers, I prefer to put this in ascending order, right? So you write your sum of min terms, and then you start with the lowest, which will be your 0, 1, I think it's a 5. Then you have a 8. Okay, sorry, I ate an orange. My mouse pad is sticky. Okay, 8. Then a 9. And then this is gonna be 11. Then 13. Then 15. Remember I said this is a sum of min terms, minimum terms. So how many terms do we have here? Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8. We had 8 terms. It means we're going to have 8 main terms, right? 1, 2, 3, 5, 6, 7, 8. 8 main terms, right? So the other option, because I don't want to waste any more time, another option is the table method with the truth table. So with the truth table, how many variables do we have? We have 4 variables, right? So 2 to the power 4 gives us this, then 2 to the power 4 is going to give us 16 combinations. 2 to the power 4 is equals to 16. So you can just use this method, this first one. This is the easiest. I learned this one here at UNISA, but we used to use the table. So I'm just going to do it with the table method as well. So here you know that you have 4 variables, A, B, C, D, right? And now here you will have, for example, 0, 0, 0, 0 for your truth table, 0, 0, 0, 1, right? 0, 0, 0, 0, and definitely 1, 0, right? So if you look at this, the easiest way to draw a truth table here is 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 16 times. Here it's going to be 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1 until you have 16 records, right? Here's going to be 0, 0, 4 times. Let me show you 0, 0, 1, 1, 1, right? So here now, this is going to be, here we know we're going to go for 0, 1, 0, 1, 0, 1. Here it's going to be 0, 0. But in essence, this is just a 0, binary 0, 1, 2, 3. This one will be a 4, then 5, 6, up until you get to 50. Right? So let's finish up. 0, 0, 1, 0, 0. And then here, 0, 1, 0. Definitely 0, 1. Okay, then here 0, 1. This one will be 1, and then this will be 0. So this is 6, this is 4, this is 5, this is 6. Now we need a 7, 0, 1, 1, 1, 7, then 8. So this will be your first one, right? 1, 0, 0, 0, then a 9, 0, 1, 10. 10 is 10, 10, right? 11, 12, 13, 14, 8, 4, yeah, 14 is like this. And then 15, everything is a 1. All right, so this is basically your truth table. So you see here is 0, 1, 0, 1, 0, 1. Here is 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. And then here it's 4 zeros, 4 ones. Here 8 zeros, 8 ones, right? So we know our truth table is correct. That's just how to double check if your truth table is correct. But remember, this is basically just binary 0. In decimal, this is 0, 1, 2, 3, 4, 5, up until 15, because you have 16 combinations. So here it's 16 rows because you started at 0. It's 0 inclusive, right? So now let's check. So now they say when we have this combination, we're going to put a main term. So we're going to put a 1, right? When we have 1, 0, 1, 1. 1, 0, 1, 1. So we're going to look for that, and then we're going to represent it with a 1. So 1, 0, 1, 1. Here it is. 1, 0, 1, 1. We're going to put a 1. Next one, 0, 0, 0, 0, 0, 0, 0, 0 is this one. We're going to put a 1, right? This one, all ones, everything is high. In this term, all these variables are high, which is the last one. So it's a 15. We're going to put a 1. Then after 15, we need a 5. 0, 1, 0, 1. We're going to look for 0, 1, 0, 1. 0, 1, 0, 1. Here it is. The 1. Then 1001, that's a 9, 1001. Going to put a 1. Then this is a 8, 1000. 1,000,000. Then this one 1101. 1101. I think it's a 13. And then the last one, just a 1. All right, so everywhere else we're going to put a binary 0. So it means when all these lights are off, we want the output to be high. Like let's say when all the doors are open, for example, the light must be on. When door D, if it's a 4-door, when the last door is let's say this is closed, right? When doors are closed, this must be on. Then when the last door is open here, we want the light to be on. So this is basically what you are telling this circuit to do, right? So, but for every other combination, we don't want a high. We don't want anything to happen. All right. So then when you write this in sigma notation, you're going to just write the sum of min terms. These are your min terms. This is your output. Maybe this was, let's say this is X, right? So yeah, your sum of min terms. Sum of min terms is equals to, can I just type it? So it's equals to this one. Let's mark first. We can mark with this one. So it's equals to this one, where everywhere where there is a 1, right? Where the combination resulted in a high. So this is basically at, so remember this is binary 0, decimal 0, 1, 2, 3, 4, up until 50, right? So we know the first row, first row is 0. Then that one is 1. 0, 1, and then this is a 5. 0, 1, 2, 3, 4, 5. This is a 5. 6, 7, 8. 8 as well, and 9. 8 and 9, 10. Then we have 11. 11. 8, 9, 10, 11, yes. 12, 13. We need a 13, 14, and then a 15. 13 and a 15. 13 and a 15. So if we compare the two, we see that we have a 0, 1, 5, 8, 9, 11, 13, and 15. So you can use any of these methods. It doesn't really matter. Any questions regarding this one? So sigma notation is always in your test. Okay, let me stop the recording, then we can move to the next one.
Good evening, sir.
Yes.
I have a question. You see from assignment 2,